The topic that we are going to learn today is page replacement algorithm. Now see, when we need a page replacement algorithm, whenever you are using demand paging or virtual paging, you need a page replacement algorithm. So what are the different page replacement algorithm we are having is first in first out, optimal page replacement, least recently used and most recently used. LRU stands for least recently used and MRU stands for most recently used. Now here the first in first out page replacement algorithm suffers from B-Ladies anomaly. Now what exactly the B-Ladies anomaly is? As we increases the number of frames, the number of page fault increases. We think that if we increases the number of frames, might be the page fault decrease, but that is not the case with first in first out page replacement policy. As we increase the number of frames, the number of page fault increases. So only first in first out will suffer from B-Ladies anomaly. Now there is a possibility that random page replacement policy may also suffer from B-Ladies anomaly, because in random page replacement policy any page can be used for replacement. The other are last in first out, similar to first in first out. Last in first out is also there, but most of the time these four page replacement algorithms are used, that is first in first out, optimal page replacement, least recently used and most recently used. Okay, now let us take a simple example. The reference string is given and their number of frames is 3. Now this is the reference string, or what are the pages has been called, and the number of frames given is 3. So as we can see, the frame is empty, there will be page fault for first 3 pages, that is 7, 0 and 1. First we will see what happens in terms of first in first out. In first out, whichever the first has come will be out first. So for 2 there is a page fault, so we have to replace any one of these 3 pages. So first 7 has come, so 7 will be replaced. For 0 there will be no page fault as 0 is already present over here. Then for 3 there is a page fault, so 3 will replace who have come the first, so 3 replaces it. Then again for 0 there will be a page fault, so 0 will replace this. Then again for 4 there is a page fault, so 4 will replace this. Then for 2 there will be a page fault, 2 will be replaced over here. Then for 3 there is a page fault, 3 will replace over here. Then for 0 there will be a page fault, 0 will be replaced over here. Then for 3 there is no page fault. Then for 2 also there is no page fault. For 1 there is a page fault, so 1 will replace it. Then for 2 there is a page fault, so 2 will replace it. For 0 there is no page fault, as well as for 1 there is no page fault as they are already present. Then for 7 there is a page fault. Then for 0 again there is a page fault. Then for 1 there is a page fault. So there are total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. 15 number of page fault. Okay, so the star indicate that there is a page fault and dash indicate that there is a no page fault. Now let us take a next strategy, that is optimal page replacement strategy. Now how optimal page replacement policy will work is, again the number of frame is 3. How the optimal page replacement policy will work, it will see for the future reference, that which are the reference string which will be used in future, that will be not replaced. Again our frame is empty, so 701 will be loaded and it will incur a page fault. Then again 2 will be a page fault. Now see, in future 0 is going to be used, so 0 will not be replaced. Then 1 is used, so 1 will be not replaced. 7 is used, but it is used after a long time, so 7 will be replaced over here for 2. Now for 0 there is no page fault as 0 is already present. Then for 3 there is a page fault, but 0 can be used in future as well as 2 can be used in a future, so they cannot replace 0 or 2, so they will replace 1. Then there will be no page fault. For 4 there is a page fault, but 2 cannot be replaced as well as 3 cannot be replaced, because in future we need 2 and 3, so 0 will be replaced for 4. Now for 2 and 3 there will be no page fault. For 0 there is a page fault. as we are using 2 and 3, we will not replace 2 and 3, we will replace 4. For 3 and 2 there will be no page fault. For 1 there is a page fault. We see that 2 and 0 is used but 3 is not used, so we will replace 1 in place of 3. So for 2, 0 and 1 there is no page fault. For 7 there is a page fault and we can see 0 and 1 is used in the future, so we'll replace 2 for 7. So for 0 and 1 there will be no page fault. So number of page fault in optimal page replacement policy is 4, 5, 6, 7, 8 and 9. You can see over here we are having 15 page fault, whereas in optimal page replacement policy we are just having 9 page fault. Now let us take a next one, that is least recently used page replacement policy. Again the number of frame size is 3. The first 3 will definitely going to incur a page fault because the page frame is empty. Now for 2 there is a page fault, so we are referring the least recently used. If we asked about most recently used, then 1 becomes the most recently used, but 7 is the least recently used, so 7 will be replaced. Now for 0 there will be no page fault. For 3 there will be a page fault. Now before 3, 0 and 2 is used but 1 is not used, so for 3 the least recent used is 1, so it will replace 3. 0 will not be replaced. For 4 again there is a page fault and 0 and 3 is referred soon, so it will replace 2. Then for 2 there is a page fault. 0 and 4 are referred but 3 are not referred, so it will replace 2 over here. 3 there is a page fault. For 3, 4 and 2 is used but 0 is not used, so 0 will be replaced by 3. For 0 there is a page fault. 2 and 3 is used but 4 is not used, so it will replace. And then for 3 and 2 there is no page fault. For 1 there is a page fault. 3 and 2 are the most recent use, so 0 is least recent use, so it will replace 0. So for 2 there is no page fault. For 0 there is a page fault. 1 and 2 are recently used, 3 is not used recently, so 3 will be replaced by 0. For 1 there is no page fault. For 7 there is a page fault. 0 and 1 are recently used but 2 is not used for a long time, so it will replace the 2. Now for 0 and 1 there will be no page fault. So the total number page fault are 4, 5, 6, 7, 8, 9, 10, 11 and 12. So number of page fault are here is 12. You can see the optimal page replacement policy is the best page replacement policy, but what problem it is having is how to know the which page will be referred in future. Okay, we are working on a future aspect in optimal page replacement policy. The next one is most recently used. Again there are 3 page frames, so 7, 0 will definitely cause an page fault. Now for 2 the most recent will be replaced. For 0 there will be no page fault. For 3 there is a page fault and the most recent, that is 0, will be replaced. For 0 there is a page fault, so most recent, that is 3, will be replaced. For 4 there is a page fault, so most recent, that is 0, will be replaced. For 2 there is no page fault. For 3 there is a page fault. For 3, 2 is the most recent, so it will replace. For 0 again there is a page fault, so 3 will be replaced by 0. Again for 3 there is a page fault, so 3 will replace it. For 2 there is a page fault, 2 will replace 3. For 1 there is a page fault, so 2 is replaced by 1. Again for 2 there is a page fault, so 1 is replaced by 2. For 0 again there is a page fault, so it replaces 0. Again for 1 there is a page fault, so most recent is 0. For 7 there is no page fault. For 0 there is a page fault, so 0. For 0, 7 is the most recent, so 0 replaces 7. And for 1 there will be no page fault because 1 is already present over here. So the total number of page fault over here is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so the total 16 number of page fault will be there in most recent use. Okay, now let us take one example that has been asked in GATE 2015 paper 1. The reference string is given and they were asked you whether the number of page faults in first out and least recently used is same or not. Now what we have to find out, first the number of page fault, and then we have to find out the difference between them, if both include the same number of page fault or not. The number of frames given over here is 5. Okay, so instead of 3 we are having 5 frames over here. Similarly here also we are having 5. Okay, so first we will do the first in first out. For 3 there is a page fault, for 8 there is a page fault, for 2 there is a page fault, for 3 there will be no page fault because 3 is already there, for 9 there is a page fault, for 1 obviously there is a page fault, for 6 there is a page fault, so first come first out, for 3 again there is a page fault, so first come first out, for 8 there is a page fault, so first come first out, for 9 there is no page fault, for 3 there is no page fault, for 6 there is no page fault, for 2 there is a page fault, for 1 there is no page fault, and for 3 there is no page fault. So total number of page fault over here is 3 plus 4, 5, 6, 7, 8 and 9. Now we have to see whether the least recently used also include the same number of page fault or not. So again for 3 there is a page fault, for 8, for 2, for 9 and 1. So for 3, 8, 2, 9 and 1 there will be page fault. Now for 6 there is a page fault, but for 6 we have to replace the least recently used. Least recently used right now is, if you see, it's 8. Okay, because for 6 this is the 2, 3, 9, 1 are the most recent, so least recent is 8. So 8 will be replaced for 6. For 3 there is no page fault, for 8 there is a page fault. For 8 the least recent use is 2, because 9163 is already used, so for 8 2 is a least recent use. Then for 9 there is no page fault, for 3 there is no page fault, for 6 there is no page fault, for 2 there is a page fault. For 2 the least recent used is 1, because 9, 8, 6 and 3 are used right now, so 1 will be replaced. For 1 there is a page fault, for 1 9362, 9362 are the most recent, so 8 becomes your least recent, so 8 will be replaced. For 3 there will be no page fault. If we count the number of page fault over here, 3, 4, 5, 6, 7, 8, 9. So we can say that both first in first out and least recently used include same number of page fault. So this is all about page fault. Most of the time they ask you to compare the page faults or which policy is the best one. Okay, hope you understood it. Thank you.